Start a new series that is data science, and we will discuss the statistics part. So I'm Swap Tripathi. I'm the head trainer of data science and machine learning, and I will be discussing how to use statistics and why to use statistics. Now, whenever we talk about stats, we always think at what time we should learn this, where it is important, is it going to get implemented anywhere? So, guys, main thing that we need to understand is that when we are working with statistics, it is the base, that is the core of data science. That means that when we are working on it, we are learning the basic core concrete concept how to analyze the data set. Now, guys, when we discuss the data science project, we have already discussed this that the initial part, the 70% of the part is data wrangling, and data wrangling part, or you can say the pre-processing part, is almost like data processing part. It is almost like data analytical part, which means will be doing study on the data set. Now, to do this study, we should understand what is mean, standard deviation, mood, what is Gaussian distribution, what is Boolean expression. Now we should understand all these things, because when we know this kind of stuff, then only we can decide, okay, this is good, this is bad. You can also say that overfitting, underfitting kind of concept is also a little bit part of statistics, because we also find outlier by skewness, and in skewness is also part of statistics. Now, guys, statistics is the backbone of complete study. So when we go for statistics, we learn about basic stuff that we should know before starting a project. So let's not kill any time on the explanation, and let's start what is statistics and how to work on statistics. So I'm Saub Tripathi, and we are starting the video now. So if we go with the traditional definition that we have for statistics, it is statistics is a discipline that concern with collection, organizing, analyzing, interpreting, and presenting the data set. Now, when we talk about all this stuff, now again, guys, what is analyzing we already know. Now, presenting the data set, interpretation, organization, what are these words? So, guys, when we talk about data set, we have several steps in it. Means we take data set as an input. Now we have a data set, we have some null values in it, we have some categorical value in it. We also might not have all the data set in a single shot, so we might have to collect data set from different resources, and these resources can be anything. Right now, just think about it that we are taking an CSV file and we are importing multiple CSV file, and one has 3 column, one has 4 column, one has 5 column. Now we need to combine all these columns together to create a single data set. Okay, so we have, I'll say, at the end we will have 11 or 12 columns in the data set. These column, okay, these particular category, the columns we is called features in data science. So it is called features. Whenever I say features, I mean the columns. Okay, so we will start with statistics. The first thing that we should know about statistics is mean, mood, and median. Now, if you talk about simple language, mean is basically average only. So I hope you remember how to take average. We have multiple values. So when we have multiple values, we take the average out of it. Okay. Let's give me 1 second. Let me close it better. So let's talk about the average part. So if I talk about the average part here, that means if I have four values, say 2, 3, 4, and 5. Okay. I have four values. What I will do, I will add these values. Okay. I will add all the values. Once I'm done with adding the values, okay. Once I'm done with this addition, I will divide this value. So I'm just using a slash here instead of the denominator part. And what I'm going to do, I will count the values. So I have 1, I have 2, 3, and 4. Okay, I have four values. So I will write 4 here. Okay, now addition of all the values divided by the n, that is called average. Okay, when we talk about mood, so when we say the mood of data set of particular column, what do we mean by it? Suppose I have category like A, A, B, C, and say D. Okay. The mode of this particular column, this is a column, guys. This is a column. Okay. I'm writing it horizontally, but think about it as vertically. Okay. So we have A, B, C, D. Now this is my column. Okay. These are my values. Now, guys, if I talk about the mode of this data set, okay, this particular column, the mode will be A only. Why A? Because the occurrence of A is higher than any other category. Okay. So the mode of this particular column is A. So we will get the output as A. Okay. So this is called mode. When we talk about median, if we take the same data set, the center value will be median. Okay. Whatever the center value we have. In this case, B is my median. Okay. In this case, because we have four values, we will pick both of the values at center and we find the average of this. So we will do 3 plus 4. Okay. And we divide it by 2. This average that I'm finding will be my middle point, the median. So 4, 5, 6, 7, 7 divided by 2. It will be somewhere around 3 point something. I hope you get the point here. So I hope it makes sense to you. So this is called median and mode and mean. And guys, these are the very important and very, very basic stuff that we have. Now moving forward, we have population. Now population sampling is a very important concept. So guys, as we discussed that we get dataset from several points in several places, we usually don't take the complete dataset. So when we have a dataset, we don't really start working on the complete dataset. What we do, we take a sample. Okay. So we have say 1 million rows. Instead of taking 1 million rows, we take say 1,000 rows or 10,000 rows. Okay, and we take this sample from the population only. This sample is random. That is what we need to mind. Okay, so we are taking a random sample and we take this sample and we do our study. So whatever coding, study, cleaning, whatever you want to do, whatever function you want to create, you create for this sample. Okay, and you already know that if it is working on sample properly, it will work on the population too. And whatever finding you are having, so whatever finding that you got while studying on this sample, you can give a probability of the complete population on that graph. Okay, I'm not saying that it will be 100% correct all the time, but at least you have a very good chance that it is correct. Okay, I hope it makes sense. So guys, what we have here is a population is this entire group that you want to draw conclusion about, and this is my population, which is the entire group of which I want to draw a conclusion. A sample is a specific group that you will collect from data. Okay, and the size of the sample is always less than the total size of the population. That means it will be less than, if the population is n, so the sample will be n minus 1 only. It will always be n minus 1. The size of sample is denoted by small n. Okay, and small n is always n minus 1, smaller than the total population. That we need to mind. That is why we are calling it sample, right? Now, what we are doing next is that we pick the value randomly. That is what should be understand, that we try to pick it as randomly as possible, so we don't have any bias inside it. Okay. Again, guys, reading the sample is never perfect. We always have some sort of bias inside here and there, but we try to be as random and as clean as possible, which is a good solution. Why we do sampling, that is the first question that you should be asking. So to reason for doing a sampling, or why we do sampling, is that we are doing this sampling so we can save our time of processing the complete data set. Suppose you start walking in the wrong direction. Okay, now you have wasted your energy, your time for processing the complete data set. Okay, and usually when you process a very big data set, it consumes time and energy a lot. Okay, so if you take the sample, it will save your time, it will be more efficient. So I hope you get the idea. Moving forward, we will try to find the mean of the population. To find the mean of the population, all you need to do is sum of all items, that how we find the average, and number of items that we are having. In this case, it will be n. and we will be adding all the values above. Okay. Sample mean will be sum of all item in the sample. So obviously whatever sample we have taken, so this is my population, and say this small area is my sample. So I will add all the values in this sample area, okay, here, and then I will subtract it from n minus 1. Guys, obviously why I'm saying n minus 1, the size of the sample, the count of the sample will always be smaller. So we already know that no matter what, it will be smaller than the complete population. Okay, I'm just adding, subtracting one for that sake. I hope it makes sense. Now we will talk about variance. Now variance is extremely important point. Now what is variance and why we use it? So guys, in probability theory and statistics, variance is the measure of how far a set of numbers is spread out from their average value. What do we mean by this? Suppose guys, mu is my average here. So mu will be considered as my average only. This is my average. Okay. What I'm doing here, I'm trying to find out how far all the my data sets. This is my data set, standard deviation one, step two. How far and how away my data set is from the average value. This is my average value. This center line is my average value, and how far they are from us. Thus, this average value. And this distance is called the variance. So guys, if I take this red dot as my average value, okay, if my points are coming here and here, so this is my called variance, and far more away they are from the average value, more away from this average means they are there is high variance. Okay, and more closer to it, if we have dots like this from average, that means it has low variance. Okay, it has low variance. I hope it makes sense. Simple, layman language explanation for this. We have scattered dots. When you use scatter plot, we will see a very scattered dots from average, and that is how we know we have high variance. Okay. So variance is calculated by standard deviation. Again, sigma square equals to summation of x, that is all my x values, minus the average value, and I'm doing the square of it, divided by the population. Sample standard deviation basically square. For sample, what we are doing, we are adding x minus x bar, okay, and we are just taking square of it, and then n minus 1. So this is called variance, and form of variance and sample. Okay. Moving forward, what we are doing, standard deviation square root of variance. Now, in standard deviation and square root of variance, we have simple formulas. So, sample variance is this x minus x bar to the square, and we have n minus 1. Quite obvious that why we have n minus 1. Sample standard deviation is similar fashion. We just put a square root. So, when we put a square root on variance, it became standard deviation. Okay, this is the relation you can say. So, standard deviation and variance has a square root relationship. Okay, so when we want to say standard deviation, we can say that a square root, taking the square root of this variance will give me the standard deviation. Okay, vice versa is also true. So square of standard deviation is equals to variance. Okay, equals to variance. I hope both of them make the sense, and they are the same thing, they are not different. I hope it is clear. So we talk about standard deviation. Now in standard deviation, we have x minus x bar square and minus subtracting it from small n. Guys, we are talking about sample here, so we are talking about small n. Okay, I hope it is quite clear. And moving forward, we have something called Gaussian distribution, and we also call Gaussian distribution as normal distribution. So both are the same name for the same thing. Okay. There's another name for this is that is called bell curve. Okay. A bell curve. So bell curve, Gaussian distribution, if you heard any kind of name, they are talking about the same thing, guys. They are talking about the same thing. So bell curve, Gaussian distribution, normal distribution is the same thing. So guys, what they really do and what we are using it for. So guys, when we plot the data set and we you could draw this KDE kind of curve, what we have this how data is dividing in the data set. So what conclusion that we have from the empirical formula? Okay, this is Gaussian distribution, this kind of bell curve. Where why we call it bell curve? First of all, guys, if we draw a center line here from zero, this is my mean value. This is my mu. This is symmetry. Means the left area and the right area is symmetrical. It is mirror image of each other. Okay, and that is why it is called bell curve. I hope it makes sense. So guys, what we talk about next is empirical formula. Okay, little bit of explanation. We have further slides for this too, but let's discuss empirical formula. So empirical formula is a you can say equations and formulas, or you can say a pure algorithm that give us the clear idea how much data is present at what kind of standard deviation. Now, the step of standard deviation means this step -1 to +1, -2 to +2. These are my steps. Okay, and we are going to find out. We already know actually that what kind of data set and how much data set is present when we take this step. Okay, in the first step we have 68% data set. In the second step we have 95% data set. In the third step we have 99.7% data set. Guys, I'm repeating again. In my first step I have 68% of the data set. What does it mean basically? That means in this area, so in this particular area we have 68% of the data set. Okay, in the second area, this is -2 to +2, we have 95% of the data set. And in the third area, that is the third step, we have 99.7% data set, and remaining is away from it. So I will get the idea. And this is why this is called empirical formula, because it is giving you the clarity that how much data is present in every step. Now, if you already know this kind of stuff, it makes a lot of sense when you actually work on a data science project, because you know what kind of data set and how much data set you're expecting at a particular area. Okay, but guys, again, as we know the practical stuff and real stuff, we can always say that bell curve and Gaussian distribution kind of thing is very rare, that it actually happens. Okay, and we have Chebyshev inequality formula for that purpose only. So guys, it is an extension of you can say Gaussian distribution, and it is a second formula. So Chebyshev has given an inequality formula. That means if the data set is not following the Gaussian distribution, okay, in case of data set is not following the Gaussian distribution, it will get implemented. Now, how it get implemented? It just says that I'm not taking from -1 to +1. Okay, the step will be not taken from -1 to +1. The formula here is that 1 minus 1 by k square. Now this k can be anything. Okay, k can be anything. So just writing k in this fashion, so k square. Okay, and k is can be any value. Okay, but obviously above 1. And what I'm doing here is that I'm taking a center value here, say this area, and this area contains, okay, 1.5 is the starting point here. So 1.5 to, you can say, -2 to +2 step, that is the area that I'm covering. So from 1.5 to plus 1.5, so -1.5 to +1.5, we have 56% of the data set. Moving forward, if we take the second part, where we have you can say step 2. So from -2 to +2, we have 75% of the data set. Okay, from -3 to +3, we have 89% of data set. And from -4 to +4, we have 94% data set. Now guys, if we calculate this, you will get the same value. So I hope you get the idea that this is used to as in, you can say, substitute of the empirical formula. The reason for that is, guys, data sets usually don't follow Gaussian distribution very easily. Okay, and if the data set is not following Gaussian distribution, we need some method or some way to describe this data set. Okay, and this particular formula gives you the clear idea that how much data set is present here and there. Okay, I hope you get the idea. So this is for Chebyshev inequality formula. So let's move forward. Guys, we will discuss covariance theory now. So let us discuss convergence theory now. In convergence theory, we have simple rules that we want to find out that how much, two features are correlated. So we get a information of negative or positive here. That means we get the idea that the relation that these features are having, a positive or negative. Now guys, I hope you understand that features means your columns. Okay, so I'm having two columns, f1 and f2. I'm saying that how much relation they're having with each other. Okay, we get a negative value out of it, or we get a positive value out of it. Okay, now what do we get? Negative and positive. And how we get it? We use x minus x bar, that is mean of x, y minus y bar, the mean of y, and I'm dividing it n minus 1. Whatever the total numbers there are, we will divide n minus 1. We are finding the covariance of x and y here. Okay, so give it you the direction if two features are related positive or negative. Okay, the first point. Second point, do not tell us the strength of this relation. Now guys, one issue is there. Think about it very clearly. Quite simple logic is there, that I give you a negative or positive number. Suppose I give you a positive number, suppose. So you can say that, okay, these features are correlated, so we should not be dropping this or this. Suppose I'm saying it. Okay, and suppose it is negative, so we decide, okay, let's drop one feature, they will not affect each other, something like that. In both the scenarios, this is not giving the strength. Suppose guys, we have just point 0.0001 negativity. Okay, 0.0001, that is very small number, a very small number. This small number is negative, and because of this negativity, we are considering that these two features are not correlated. Now as you can see, it is not the scenario, because if the relation is so close to zero, there is a good chance that they have some sort of relation. Okay, and we can dig in and we can find those relation. Now just getting the negative and the positive value is never enough, and that is why covariance is not that much famous, because it is not giving the strength is really required. And strength basically means that we should know this number. Okay, this is called strength. So what is the number, how much negative and how much positive this relation is, and that is what we call it finding the covariance relation. So concluding this, let's move forward. So x bar and y bar means x or y. So I hope you get the idea. Mean of x and y, and this is the main logic of covariance. When we move forward, we have something called Pearson correlation coefficient formula. Okay. Now what we will do, we will write rho xy. Okay, covariance xy, and we have sigma of x, sigma of y. Okay, moving forward with this, we will be doing e x minus mu x, y minus mu y. Now when we do this and we divide it with standard deviation of x and standard deviation of y, we get the strength too. Now guys, notice this, that the first part is the covariance formula only. Okay, we are just adding this division part, and by dividing this we get the strength. Now what changes here? Suppose we are getting plus 5 relation. Okay, first plus 5 value, so we know it is from 0 above plus 5 related, so this is a good relation, we can say strong relation. I'm just giving you an example here. Basically it does not go like that, it is from -1, the range is from -1 to +1. Okay, and as much it is towards +1, more correlated they are. More it is towards -1, it is less correlated. Okay, and 0, I hope you get the idea, it is not going to affect anything. So more it is towards this direction, it is more related, and more it is to the negative direction, less it is related, but we at least know the number. By having this number, we have the strength to find out, okay, how much they are correlated, how much they are affecting to each other. Now gives you direction in if the relation between the two features is positive or negative. Also tells you the strength, and E is for epsilon. So E here in this area is basically epsilon only. Okay, so that is what I'm saying here. So I hope you get the idea. This is called Pearson correlation. And if you recall the seaborne part where I started from -1 and +1, the heat map. Okay, it was Pearson correlation only. Okay, I did discuss this Pearson correlation there, and did told you that I will discuss this in statistics. So this is what Pearson correlation is all about. I hope you get the idea, and let's move forward. And if you can also recall that heat map, that we have color combination and we had number. So both having both of them together makes a human. It is very easy for a human to point it out where we having less correlation, where we having a high correlation. Okay, I hope you get the point here. Moving forward, what we will do, we will also check the projector of the line when we talk about the correlation. So when we have this kind of line, okay, this straight downward direction line, it means the Pearson correlation is -1. Okay. When we have this kind of line, which is above same value at x and y, almost same value at x and y, we can say that relation is between -1 to 0. Okay, and if we are having the line in this direction, so we have the value between 0 to 1. Okay, and if it is on the y-axis, the intersection point is on the y-axis, we can say the relation is definitely 1. Okay, and if they're scattered like this, as you can see guys, it is completely scattered. So no matter which line you draw this line, this line, this line, it will never get all the points together, or points closer to the line. We will call it 0. So Pearson correlation in this scenario is 0. This is the formula, same formula. I hope you get the idea and get the line plotting part. So moving forward, we will discuss about variables. Now, what are variables and why we use it? Now guys, when we talk about null values, when we talk about categorical values and stuff like that, we need to discuss these values. So variables are very important when we are handling the data set, especially with pandas. When you do the pre-processing part, knowing the types of value is very important. Okay, so when we talk about values, we have some sort of numerical values, so we have some sort of categorical value. So categorical value is like male, female. Okay, that is called category value. We have a column that is sex, and in sex we have category value. If you recall the Titanic data set, this was the these were the values. Okay, if we talk about numerical values, we have numbers. So 2, 3, 4.6 kind of numbers are in numericals. Okay, 4.6 is a number. So any value, whole or you can say decimal value, is in numerical value, and any categorical value like male, female, A, B, C, D kind of stuff is in categorical value. Now we move further. If we move to the down to the leaf part and of the tree, we will notice that it has further division. This division is continuous, discrete, and in category we have ordinal and nominal. So let's talk about numerical first. Okay, so in numerical, it means that we have in continuous, we mean that we have 1.0, this kind of numbers, 1.2, 2.3, and 3.4. We have these kind of numbers. When we talk about discrete, this discrete part, okay, this discrete part, it means whole numbers like this, 2, 3, and 4 kind of number. When we talk about ordinal data, we mean that data set has some sort of order. So this category that we're having, it has some sort of order. I've given an example of degrees. So PhD, MTech, and B. So guys, I'm MTech. So anyone who has done B will be considered, his degree will be considered less than mine. Anyone who has done PhD will be considered a degree higher than mine. Okay. So this is called the ordinal data set. Let's talk about nominal. So in nominal, we don't have any order. So basically, it is like ABC or XYZ. We don't really have, we cannot say A is greater than B or B has a higher order than A. Nothing like that. Like male and female, we have no order here. Both are equal. So this is called nominal data. So I hope you get the idea, especially for categorical part, because when we talk about encoding, we also need to decide which encoding to implement where, and it is very important. So I hope you get the idea, you got the clarity here, and let's move forward. Central limit theory. So when we talk about central limit theory, we have very clarity, very simple statements are there. Whenever you're taking sample higher than 30% of the complete population, you can say the mean of the sample will be somewhere equivalent, not exactly equivalent, but little bit equivalent to the population. So average of population is little bit equal to the sample. So the central limit theory states that if you have a population with mean mu and standard deviation sigma, and it takes sufficient large random sample from the population with the replacement, then the distribution of the sample mean will be approximately normal distribution. Okay. Now, this is talking about distribution, and this is talking about, this particular example is talking about the mean part. So I hope you get the idea. Of course, in both the cases, the expression is same, and we can say the this is my population. So n is 10. This is my sample, and every sample has a mean approximately equivalent, close by to 63, 65, something like that. So I hope you get the idea here. And this is all for the statics part, the theory part that we have discussed up to this point. And further, we will discuss how to use it when we actually work on the data set.